number 6.2 using intercepts. Hopefully you guys are liking these videos. I'm hoping that they become a huge success with you, so go ahead and let me know in class when I see you guys, or tweet me on Twitter and let me know if you are enjoying these videos. I'm trying my best not to make them super weird and awkward, so let's just move on. So here we go with 6.2. We have an essential question that says, how can you find and use intercepts to model real-world linear relationships? I'm going to go ahead and leave this explore activity for you guys to do on your own, and we're going to go ahead and flip over to page 164. So right here at the top of the page, you see that it says finding intercepts of linear equations. So you see here your very first vocabulary word is the y-intercept. Well, intercept basically means to cross something. When it's crossing. So the y-intercept is whenever you have your line that is intercepting or crossing the y-axis. So in this case, the y-intercept is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always 0. So it's really important that you underline that and that you keep that on your mind, because that is something that you're going to have to know later on. And so the exact same thing but in reverse is what the x-intercept is. So in this case, your x-intercept is whenever your line is intersecting at the x-axis. And your y-coordinate of that point is always going to be 0. Okay, so let's go ahead and look at example number 1. You guys can see here that it says to find x, y intercept. So here you see you have your regular coordinate, and in blue you have your diagonal line that's cutting across your x-axis and your y-axis. So in this case, your x-intercept is -4, and your y-intercept is also -4. Now notice here that it's telling you that the graph is crossing the x-axis at -4, 0. Whenever you are asked to write your intercept in the form of an ordered pair, this is what you want to show. So if you're talking the x-intercept, your y is equal to 0. And when you're talking y-intercept, your x is equal to 0. And my mistake, I could have sworn that this was crossing down here. Obviously, it's not the -4, it's the one right above it. It is -3, and that is why your y-intercept is -3 or 0, -3. Okay, when you are given an equation like this one for part B, it says 3x minus 2y equals 12. In order to find your x and y intercept from there, you're basically going to be substituting 0 for one of those values to find the other value. So for example, in order for you to find your x-intercept, you want to replace your y value with 0, because as we saw up here, when you have your x-intercept, your y value is 0, because you didn't move up or down. You stayed right here on the x-axis. So that's what you're going to go ahead and do here. So you substitute this value in your equation, your y value, you substitute it with 0. That cancels out. And so you're left with 3x equals 12. You go ahead, you divide both sides by 3 to get that x by itself, and you have 12 divided by 3, which is 4. So the x-intercept of this line is 4 or 4, 0. And then when you go ahead and do the exact same thing for your y-intercept, you're replacing your x value with 0 now. So you're always going to be replacing the opposite one. So in this case, you're going to go ahead, you have 3x, substitute for 0, that cancels. You have -2y equals 12. So you have -2y equals 12. You divide both sides by your -2, that cancels out here. And positive 12 divided by -2 gives you this -6. So your ordered pair in this case is going to be 0, -6. Okay? So I want you guys to try to do the your turn question on this page on your own. Remember, here you're just basically looking at these 2 points, and over here I will give you a clue. In order to find your x-intercept, you're going to make your y equal to 0. And in order to find your y-intercept, you're going to make your x equal to 0. Okay, so you're going to go ahead and solve it and give me those answers. Let's move on to page 165. So now we have interpreting intercepts of linear equations, And so in this case, you're basically talking, whenever you see interpreting, you could see from right here from this particular example, it has to do with real world situations. So what do those intercepts mean in real life? If you're talking about specific real world type of situations, basically. So in this one here, it says the Sandia Peak Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute, and the function f of x equals 4,500 minus 300x gives the tram's distance in meters from the top of the peak after x minutes. So we want to go ahead and graph that function to find the intercepts. And then we want to describe what those intercepts represent. So you see here that what they did was they chose different x values to substitute into this function, and then they basically just went ahead and did order of operations to find out what f of x equals. Remember, f of x is the same thing as y. Okay? So once they went ahead and they graphed it, you can see what the graph looks like here. And so it says here that your y-intercept is way up here at the 4,500, and your x-intercept is somewhere over here at the 15. Okay, so what this means, if you know that this is your distance and this is your time, well then that means that your distance here, your y-intercept, it says here that in the real world, the y-intercept represents the distance from the top at the start. So the time was 0, and at 0 minutes, it was at 4,500 meters. And so over here for your x-intercept, we're talking about the time again with the distance. So that means that at 15 minutes, which again is your x-intercept, so at 15 minutes you are at 0 meters. Okay? So again, as usual, go ahead and I want you guys to try those your turn questions. I'm going to go ahead and flip over to page 166. So here we are talking about using intercepts to graph linear equations. Now, in this case, this is where we're going and basically using the same things that we just learned in example number 1 on how to find intercepts, and then we're going to go ahead and use that to graph. So we have 2x minus 4y equals 8. You can see that they solved the x and y intercept. So again, when you're looking for your x-intercept, you're making the y equal to 0, and when you're solving for the y-intercept, you're making your x equal to 0. You solve. Here you see that your x was 4, your y is negative 2. So all you're going to do on a graph is simply plot those points. So x equals 4, you're going to go straight to the 4 on your x-axis. If your y equals negative 2, you're just going to come down to the negative 2 at that point. It's as easy as that. Same thing with example B. The only difference here was there were fractions involved. Okay, but you're still solving it exactly the same way. Keep in mind here, when you are solving and you have a fraction, in order to get rid of a fraction, you are multiplying by the reciprocal. Okay, so that's how you get your x by itself. In this one for the x-intercept, you're going to simply multiply by the reciprocal of 1/2, which is 2. So you're multiplying 2 on both sides. Okay, in order to get your y by itself on this side, the reciprocal of 2/3 is 3 over 2, and that's what you'll be multiplying. So 3 times 4 is 12, divided by 2 gives you 6. All right. When you go on to the actual graph of it, you see that it looks just like that. You're just plotting those points. All right. So in that reflect question, it's asking you to find the intercepts for a linear equation of the form ax equals c, where a and c are real numbers and a is not equal to 0. What kind of line is that, first of all? Now, if you think back to lesson 6.1, which was the second video that I made for you guys, the one that says 6.1 part 2, that one we learned about horizontal and vertical lines. In this case, if you have ax equals to c, then that means that you're talking about a vertical line. Because if you have ax equals c, that means that you have an x value equals a constant each time. And if your x value is exactly the same every single time, you're going to have a straight line going up and down. Okay, so if you have a straight line up and down, then your x-intercept is going to be c divided by a, because you're going to need to divide by this constant or this coefficient in order to get your x by itself. So in order to get your x-intercept for this particular line, you would have c divided by a. And at that point, you're not crossing the y-intercept or the y-axis because it's a vertical line. Okay, so if you have a vertical line going straight up and down, you will have no y-intercept. All right, so now in these your turn questions here, it says to use those intercepts to graph the line described by each equation. All right, so you're basically going ahead and I'll go ahead and do number 6 for you guys. So if I want to find my x-intercept, I'm basically canceling out my y, because in order for me to get my x-intercept, remember that I need to have my y equal to 0. So if I make my y equal to 0, it cancels out. So I'm left with negative 3x equals negative 12. When I divide by 3 to get that x by itself, I'm left with positive 4. And I'll show you over here. So if I have 3x plus 4y equals negative 12, I make this equal to 0, it cancels out, I'm left with this. I divide both sides by negative 3. Negative 12 divided by negative 3 gives me positive 4. So this is going to be my x-intercept, and that's going to be right here. Okay, using that same idea with my y-intercept, I'm now going to make my x equal to 0. So I have 4y equals negative 12. And again, when I divide by positive 4 on both sides, I now have that y equals to negative 3. And so that's going to be somewhere around here. And now that I have my 2 points, I can go ahead and just put a line through both of those, hopefully better than this. Hopefully you guys are using rulers. And so that's what it would look like. All right, so let's go ahead, flip over, and I'm going to do about 1 or 2 of these questions with you guys, and then the rest of it is what I want you guys to do for your homework. So in this case, for question number 1, it's asking you for the x and y intercept. So I'll just kind of point it out for you. You'll see here that there's a dot right there, so that's your first point on your x-axis right here. That's going to be x-intercept, and this point right here is going to be your y-intercept. So our x, you see here that this is negative 1, negative 2, negative 3, negative 4, so it is at negative 5. And your y is at positive 1. Okay? Don't forget, when you guys go to do these here for number 4, 5, and 6, you're going to make your x equal to 0 to find your y, and make your y equal to 0 to solve for x, just like we did in the last one. Okay? And you're going to do the exact same thing actually for number 7 and 8. You're going to graph them using those intercepts. So you're going to do the same thing for 4, 5, and 6. You're just going to graph it afterwards. All right, and that concludes this video, guys. Hopefully it wasn't too bad, and let's see how it goes. I'll see you guys in class, and have a good day.